All right, so let's start. I will try to stick to the time. Just do let me know, is it for nearly 40 minutes, right? So I timed it for 35 minutes, leaving 5 minutes for questions and answers, but I can go faster or slower. Gaurav, Ramana?
Yeah, that's fine.
Okay.
35 minutes.
Fantastic. Okay, great. So hello, everybody. I am Ahmadi. I am a reader in digital engineering, and this is basically presenting the work that we do in the iTwins lab. So generally, I'm going to talk about Open RAN today for you, and I want to put the title Connecting the Unconnected. So just because with Open RAN, we can do loads of interesting stuff. But before that, I want to do a little bit of a sort of marketing stuff and say that what we do, who we are, and why nowadays we are doing this Open RAN activities. So basically, in York, I'm leading a group of PhD students and postdocs. And in this group, we have a lab, and our focus is basically intelligent, trustable wireless networks for society. So it is very important that we keep important stuff for the society. So we should not, as researchers, disconnect from the society. And some of the current society issues is sustainability, green communication. To deliver that, we basically work on machine learning. So I personally, since my PhD, which was years ago, I started working on machine learning, and I'm telling normally that I do machine learning since the time it was not cool. So many of my papers got rejected from our dear ComSoc friends, and they saying that, oh, this machine learning is not going to be fly at all. It's not good. Neural networks don't work. Things like that. But nowadays it is becoming more popular. Everybody knows that. So we do work on modern RAN. We do work on the private networks, digital twins, and different types of activities in Internet of Things, including the blockchain. But let me go and introduce my team. So this is my team. We are working in a place that is called Institute for Safe Autonomy. If you can see here, that's 35 million pounds institute funded by Research England and University of York. Our focus is on safe autonomy. We have 4 different pillars: autonomy, safety, and trust. Well, assurance as well, and communication and ethics. So I am the deputy director of the communications pillar in Institute for Safe Autonomy. And there, as mentioned, we consider safety, assurance of machine learning, and also ethics. So it's a very nice combination and a very modern and up-to-date combination of the activities and teams that are working together. As mentioned, the main focus is modern AI, digital twins, Open RAN, and NTN, which I'm going to discuss in more detail to you. And our works are funded by these different funders. Specifically, our ORAN projects are UK government funded, which are basically YORAN and REACH. They are both UK government funded. There is the digital twin for Open RAN networks, or ORAN twin, and it is an EPSRC funded project as a part of the Cheddar Hub. And other than that, I want to use this opportunity basically to tell more about the role of AI for good, because University of York is have the slogan and the idea that we want to be the university for public good. So we have to use our knowledge and our reach for doing good things, right? So one of the ways to do good stuff is using AI for society. And as a result of that, we have several projects running, and they are funded by different groups. and doing good stuff for the society using AI. The first EPSRC-IAA activity is the, again, green, secure, and privacy-aware AI for sustainable network and autonomous systems. There we work on the modern algorithms that are energy efficient and they are basically privacy aware. So mostly distributed algorithms of AI and ML for autonomous systems. We also use our abilities in smart digital platforms for connecting the unconnected, like the indigenous communities in countries that are with lower income, and these have got basically affected by the climate change. Big and smart cities are basically always having issues with the pollution and air pollution. So there we actually have the project that we do the crowdsourcing and taking the AI and the trustful data collection into the picture. This is with the Istanbul Technological University, a Royal Society project. And the other project that we do is a worldwide university network project led by the University of Sheffield in collaboration with the University of Auckland. And there we are looking at the ethical integration of AI for digitalization. So nowadays we have loads of workforce, and then we are going through another sort of industrial revolution with all these generative AI. And many people are worried of losing their jobs. So we want to make sure that we have investigated this topic and we know that how the ethical integration of AI should be into the workforce. These were basically some of the marketing stuff I wanted to tell you about the activities that we do. So you know generally who I am, why we are looking the Open RAN from this particular angle, and how our work goes towards the Open RAN. I hear some noises on the back. Do you hear me well?
Yes.
Yeah, okay, fantastic. Thank you very much. So now let's get into the technical stuff and the detail and Open RAN. So the first important issue is to motivate our work and say that, okay, why Open RAN becomes so important these days? Why Europe, US, and UK are all funding projects on Open RAN and are all focusing on this interesting topic. So basically, let's see what is the problem at the moment. So the current problem is that the current radio access network is vendor locked. So, and there are a number of vendors. So it's like a type of multiplayer market. It's Nokia, Ericsson, Huawei, a few of them, and they all have basically services provided, equipments. They sell the network infrastructure, and they all come as a package. So the customization that the operators want to do is defined within the boundaries that the vendors are providing. So the vendors are telling you that, okay, you can do this, or no, you can't do it. It's locked, like the software that you have for example, you get from Windows. It's not like a Linux system that you can play with it. So the innovation that operators and the users can provide is basically vendor controlled, right? So the vendors are again having an oversight, a control, and on the innovation, and basically the users, the operators need to comply with that. So that is one thing. The next issue is there is no room for smaller players, especially on the software side. So you don't have any room to basically play or get involved unless you're making a deal with the big operators or with the basically big vendors. So if you want to have if you have a board or a radio card that is very good, you need to get it into products and the roadmap of big vendors. You have a nice software, it's a challenge. How you are going to get it, how you are going to market it, how you are going to improve it again. The access to the data is also limited, and that makes the integration of machine learning and integration of the modern approaches into the current networks challenging. We all say that okay. Also, in the previous talks, we possibly have heard that 6G is going to be the AI native generation. A lot of talks about this have been done, papers on 6G saying. But when everything is locked, the control of AI is again out of our hands. So the innovation cannot happen there. So this issue have been understood by many players around. And then there is this Open RAN concept came into the picture, so that we can basically open the architecture. And when we are opening the architecture, we can let other players come in. Of course, the big players still are there. They have the advantage, they have the capabilities, but we also allow others, smaller players, to get in. We allow the innovation to come in and carry on. So this is the general architecture of Open RAN that I'm showing you here. And there are key inventions in this. There is a disaggregation. So the network in Open RAN architecture is disaggregated. There are several separate parts. And these are actually, I needed to put this a little bit higher. These are connecting through open interfaces. So basically, if you have open interfaces and you can connect different parts from different vendors to each other, and through these open and well-defined interfaces, they can talk to each other. Basically, you are satisfying the requirements of the disaggregation, because there is a way to get one component from another vendor and connect it to another component from the other vendor. These interfaces are now open. You know what is going on. You know how to connect these, and there are basically a standardization regarding that. So this is one of the innovations that is happening in the ORAN. And this is coming through virtualization. So we have the virtualization, and through virtualization, basically we have these system enabled. Virtualization is nothing that we are not aware of it. It's not a specific innovation that we don't know about it, or invention. That it has been used in the wired networks. On the network side, we have the NFVs, microservices, loads of other stuff. So, but in the RAN, it is fairly new. And this, again, enabled the next steps. Another good invention in the architecture, a new thing in the architecture, is the component that is called RIC, or RAN Intelligent Controller. We have two of those in Open RAN, and those are the ones that they are helping us to put the AI in. Let's have a look at this part, the architecture. I'll tell you a little bit about it, and then we can look at the RICs in more detail. So have a look that we have ORAN interfaces, and then let me actually tell you one tiny thing that we need to know. When we are talking about the Open RAN is the general architecture, the general concept. But when we say ORAN is not necessarily an acronym for Open RAN. ORAN is the specification that is defined by an alliance that is called ORAN Alliance. And this ORAN Alliance includes basically all the big players in the ORAN community. So Ericsson, Nokia, Microsoft, Facebook, Red Hat, and University of York also, and University of Bristol. Some of the academic and industry players are involved in OLAN Alliance, and they have different working groups. They have very similar to any alliance or in standardization bodies. So there are in this architecture you see here that there are 3GPP interfaces. There are ORAN interfaces. So this O1, O2, these are interfaces that are defined by basically ORAN Alliance. And also we have the E2 node, which is consisting of the OCU, ODU, and ORU. So that's the central unit, distributed unit, and radio unit. And if you look at here, we have the RIC, or near real-time RIC, and you see that the loop is basically between 10 milliseconds to 1 second. So that is the part that basically near real-time RIC activities are placed. Non-real-time RIC is placed in another component in Open RAN that is called SMO, which is the Service Management and Orchestration unit. And this is normally having above 1 second loops of control. So near real-time RIC has third-party software that we call it XApp. So I don't want to jump ahead from myself, so we can go to the next slides. Just have a look at this. We can come back to this a lot. Just remember the E2 node and the E2 interface. Remember that the E2 interface is connecting to OCU and ODU. There is no direct line from the interface to ORU on the E2 side. And RIC is connected through the E2 interface to E2 node, basically DU, and controlling many functionalities on RUs through DU. And also it is connected through A1 to SMO and the non-real-time RIC. This is how basically the whole thing works. And through O2 node, SMO is connected to the cloud. So let's delve into the RICs in more detail. So as I mentioned, the near real-time RIC is connected to E2 nodes. And in this, we have also connections through A1 and O1 to non-real-time RIC and SMO. There we have basically standardized functions. So like the security, XApp management and subscription, and databases, data shared layers, and function management, AI, ML support. And then here we have potential third-party apps or applications that are called XApps. Do not mistake this with other applications on your mobile phone. These applications are basically software that run on the infrastructure. So these are the software that you are or the third parties can implement. So remember that I said that there is no room for innovation in AI, for example, in the existing architecture for the smaller players. Now I can show you that here as an XApp or our app, our apps are here, there is room for the smaller players. There is room for the third party. So for example, I can show you later on our works, but if you want to have a software developed and gain the additional control for a specific part of the network, you can develop it as an XApp. So for example, energy efficiency for a particular network can be done as an XApp or particular part of the network. So you can have different strategies at different parts of the network. This is what is happening through the XApps. So the XApps are here. In the non-real-time RIC, you have a little bit more complicated scenario. And then there are the third-party apps that are called R apps. These R apps are more policy relevant. So they are having a higher level of control in a way, or their control loops are slower. So in the second level or multiples of seconds. So again, we have the termination point and A1 that is connecting it to the near real time AI/ML workflow. As you can see, data. Sorry. Okay. Do you hear me well?
Yes.
Yes. Okay. Very good. So these are the parts that we have at the non-real-time rec. So we have both of them. And now let's have a look at some other issues. So I want to tell you more about the AI and ML in ORAN, right? So as I mentioned, in ORAN architecture, well, okay, let me go. I'm putting these slides in a form of more summer school, so a little bit more like a tutorial for you guys. But I skipped the parts that are relevant to disaggregation and the 7.2 split or 8 split. So those are the parts that we are not focusing on this. They require their own big session and the way that they have been done. I'm mostly focusing on the RIC side of the work, and that is more relevant to my group and my works. And I think for this community, this is more relevant. So to develop AI and ML in ORAN, we like any other part, we need data collection, and this is normally what is not happening in general points, right? So data collection and achieving data is a challenge, right? We need to prepare it. The data need to go through some training, model clarification, and here we can have a component that manages the AI and ML model with tuning it up and then deploying it. There we can go to the inference stage, and then we have the basically operation side of it. So these are all going to be connected to the other components of ORAN, like ODU and OCU. And this gives us a general higher level vision of how normally this AI and ML should be deployed and be done. However, there is a challenge. The challenge is that, have a look at this table. These diagrams, this one and this table are coming from our very nice paper done by my PhD student, Xuan Yu. It's about the energy consumption of machine learning in Open RAN, a review paper that we have done and it has been published in IEEE Access. There you can see there are different scenarios defined by the ORAN Alliance on how we can deploy and how we can actually support AI and ML in Open RAN. Some part of it, you see the training is going to be on non-real-time rec, data preparation, non-real-time rec, but then some of them are in near real-time rec or even in SMO, inference, non-real-time rec, or sometimes even in one scenario, it's going to be on ODU, OCU. And again, model management is in SMO or in some cases in non-real-time rec. So it's a complicated and different basically suggestions or recommendations to implement this. So what happens now? Of course, this is very good in terms of flexibility. Oopsie. So my case is that, okay, this gives the software companies, this gives the operators to have the flexibility of deploying the AI and ML in different locations and training them and having the way that it works for them. What is the challenge? The challenge is going to be interoperability. Interoperability is going to be a challenge because then your AI, your X apps that are using AI and ML may not work with another RIC. Remember that RICs are also software that are developed by different companies. So for example, we have near real-time rec that is developed by, for example, here it is, by IS Wireless or OSC, which is the open source community, or Accelerant, different companies. And similarly, near non-real-time rec. So these working these together, interoperability with the XApp that are provided by another group is going to be a challenge. So this is becoming a challenge here. All right. So we know about ORAN, we know about the architecture, we know about REX, we know about how we can integrate that into the existing systems. We know how AI and ML should be or could be integrated in that. So, and also we know the challenges in the interoperability. Okay, so now let's have a look at some of our basically innovations. So, and also if you're interested, I really recommend that you read this paper. This provides a very nice tutorial about ORAN and also at the same time with the focus on energy efficiency and energy consumption, basically. So if you're working on green communications, this is something that I recommend you to read. So this part is our innovation. This is not published yet. We submitted, but not published yet. So this is our AI engine. We say that, okay, to maximize the interoperability and interacting with other components, you can basically bring your own AI. So you can have your AI as an XApp. We call it the AI engine. And this AI engine is provided that we have connections to the database as an XApp. We create the connection data to the E2 nodes, and then having the model and having the data pipeline, we clear the data, we do the pre-processing, we do model training, and we prepare everything. And then the client XApps here, you can see my cursor, right?
Yeah. Yes.
Yeah, okay. The client XApps here are basically using the train model when they request it. So you can have it as a sort of XApp that you provide. So let's say that you are a software company. You are going to deliver some energy efficiency XApp. You can bring two XApps as a bundle. One of them is the AI engine. One of them is your energy efficiency XApp. Or your AI engine can sit as an R app, and X app is going to be your energy efficiency or energy saving X app. So as mentioned, the main functionalities are going to be data fetching and AI ML model training, cleaning the data, because a lot of times that you get data from the model from the network, many parameters could be missing. The data may not be exactly as you want. So that is something that you could have in mind, and it is a part that is going to be useful. All right, so this is our innovation. This is our part that we are doing here. But let's say that where we can use these R apps and X apps. So we can consider several use cases. The energy saving is one of the lowest hanging fruits. It can be in a single band, it can be in a multi-band scenario, it can be different cases like a smart factory. Then we can have network slicing for public safety. Again, network slicing for URLC scenarios, the smart factories, and also we can have localization and positioning. So remember that localization is something that is nowadays very popular. But with digital twinning and other things that are going on. And then there basically X apps and R apps and AI-based X apps and R apps can help us a lot. And this is one of the things that we are pursuing in our DCIT funded projects. So I want to give you more use cases specifically regarding the energy efficiency. And we are looking at 3 different scenarios. One is an HDD, highly dense deployment. And it is going to be on the very nice city of or seaside town of Blackpool. So as you can see on this side, they have loads of base stations or access point deployed. But Blackpool is very busy during a Strictly time, during the lights, during the air show, during the weekends. But there are times that the Blackpool promenade and seaside area is not that busy. So we can actually save energy by turning off or turning the RUs into the sleep mode or the access point. And there is where our intelligent X app can work to maintain the coverage and provide the energy saving or energy efficiency. And as I can tell you here, that compared to, for example, some of the very beautiful things that in the previous talk Aryan was talking about it, these are not very highly theoretical out of the papers and stuff. This is very much higher TLL being implementable, and this is the beauty of ORAN. If you have a fantastic ML that can be connected to a specific feature of the network, you can deploy it and you can see the results in a quicker way compared to waiting for 6G to become a standard or a vendor gets your algorithm and pays you a lot of money. So hopefully this is basically lubricating and making the innovation much faster. The other use case that we are looking at is the smart factory. And there is basically where we are working with AMRC, which is the Advanced Manufacturing Research Center in Preston. It's a facility of the University of Sheffield. And there we basically develop X apps and R apps for energy saving for their factory. The difference is that there it's not an HDD. And also we know when the factory is going to be on, when each machine is going to be off. So basically the network goes to sleep after the machine's work is done and comes back to the life when the machine's work is going to start. Of course, the setup time and all of these need to be considered. These can be used in private network or public networks. So there is a very nice separation of the data in a way that you want to train your network for the public or private networks. And then at AMRC, they have this Boston Dynamics robotic dog, where it can go around the factory and check the machinery and do some other activities. We need to control this potentially. We might be able to control it remotely using URLC apps for network slicing. And also this can also work with the energy efficiency and energy saving XApp. So there are loads of applications from the URLC, from the public safety. Imagine this robotic dog can go to the mountains and search for the people that they are in need. So they require the network, and that is where we basically work for that. All right. So I'm going to show you an AI ML energy saving XApp that we developed. So these are the parameters. We use the Viavi rig simulator for this case. As you can see, we have the AI engine. So this is the workflow of the AI engine. I don't get into detail. I think I don't have too much time. Can you tell me how much time left for me? Please.
Around 5 minutes.
Around 10 minutes. That's fantastic. Thank you. So yes, so you see that this is our energy saving XApp, and this is the AI engine. So it works with the ORAN nodes, and this is sitting in the near real-time rig. We have the data collection, model training that is happening here in the AI engine, and then we have the deployment that is where it is happening at the energy saving XApp. All right, so this is the integration. So integration is very important. So we get the KPMs from the RAN scenario generator and the rig tester. it goes to the AI engine through the REST API. Then the action or actuation is happening, model trained, going to the energy saving XApp, and then the actuation is happening at the VRV read test. So this can be implemented in the real test bed as the next phase of the project, and that's what we are currently working on. So the scenario, basically, we have 12 RUs. Each one of them have multiple, here, 2 radio cards working on 2 different bands, N77 and N78. And they have the transmit power, the defined height, and the number of UEs, the required data rate for the UEs. So let me show you. Oops, I think this is the video that is, I want to show you. I hope that it works. Used to work for me before. Yes. You still can see the video, right?
Yes.
Yeah. So I am I'm putting down the voice of there, but here is the scenario. We have 50 UEs, and we have the 12 RU as I mentioned. So you can see that all RUs are on. They are, well, they have overlap. So this is only the nominal. So it's not necessarily showing the exact coverage area. So the coverage area is overlapping a lot. So you see that the RAN scenario generator shows that the power consumption of each one of these RUs, depending on the number of UEs that are connected, and the red and the green UEs show that which radio card they are connected to. So now we are going to start the energy saving XApp. So the XApp is starting. As you can see, we are starting it. It is going to get connected to the environment, and it starts working here. So as you can see, it starts turning off. So this red here means that one RU radio unit is down. It's put to the sleep mode. Again, more are in the sleep mode, more on the sleep mode. And when we put them to the sleep mode, we hand over the UEs to the neighboring cells. And as you can see, on and on, this is basically doing the job. Of course, this is a already trained method, and the training is happening previously where we are having the UEs on the scenario moving and going on. So you see that there are loads of RUs in the very, very limited mode. That is the minimum sleep. So their minimum power consumption. Some of them has higher power consumption because they have more UEs attached to them and they are serving them. So, okay. Okay. So that was the video. And then now I can show you the results. So the AI algorithm have worked, and we show that we have 2 different XApps using 2 different deep Q learning algorithms. And we can see that we basically can achieve higher power saving with different one of them, right? So you see that when we have lower number of UEs, there's not much difference between them. But when we have denser environment, we can save much better with the more complicated one and more advanced, basically. So similarly, here we can see that the number of RUs that we turn off is in this case higher. This is very interesting in the sense that we developed 2 different XApps in a very short time by basically improving our machine learning algorithm. And this is what I was talking with the speed of innovation. So you can actually develop algorithms, test them, run them, deploy them as XApps, and give it to the network, so the network can actually perform better. So this work has been published again by my PhD students and postdocs, a team. We worked on it as a paper in Wincom in Leeds, actually in July this year. Very, very new work. And we got the best student paper award. So thanks to the organizers, and also it shows that the importance and the quality of the work. So now I want to move a little bit beyond what is common in Open RAN and tell you a little bit more about the potentials. So non-terrestrial networks are another potential for the Open RAN. As you can see that we can have ODU, OCU, near real-time RIC, and non-real-time RIC in different layers of an airborne network. This airborne network can be a helicite, or it can be a HAP, or satellite at different levels. So, and this have been a part of this architecture. I've been a part of a project that we have done with DCIT again, back in the days, DCMS, Mobile Access North Yorkshire. As you can see, we deployed, and we designed, developed this payload, and we put it on the helicite, sent it up in an area called Forbidden Corner in the North Yorkshire, where there is no coverage. And we provided a 5G coverage with 1 kilometer range, and 4G with 3.5, if I'm not mistaken. This is my colleague, Professor David Grace, and our work have been covered by BBC Click. So also this is a paper on IEEE network. I don't know if I put the link or not, but here are some of the results that you can see later on in this part. Another part is another good use case for 6G is using Open RAN for digital twins. So as you potentially know, or possibly know, I've been working on digital twins for a very, very long time. Again, since it has started, similar to Ramona. And we showed that these in our IEEE Communication Standards magazine paper, we show that this basically loop exists in designing until deploying an expansion of the network. And using basically digital twin enables the whole process to become smoother and better for 6G. Now we can combine a lot of these with Open RAN, and having XApps helping us with the AI part, having XApps to replicate some of the parts of the network. And more importantly, this data extraction at different points can be done through the RIC. So again, we can have XApps that they just collect the data from the RIC and let us learn about the and show it to us, and let us learn about the network more and more. So I know that I don't have too much time, so I don't want to keep it here a lot. So just want to say that open networking and Open RAN have high potential for supporting innovation and tailoring solutions to the use cases. Digital twin are also playing an important role in that, and enabling the new functionalities for ORAN and open networking. So this is my contact email address, blog, and Twitter if you follow sometimes. Also, I'm active on LinkedIn. And I'm sorry again not to be there in person, but I'm also a traveler salesman. As you can see that I have a book. I wish I could give you all a free copy of that on digital twins for 6G, but IET didn't give me enough samples. But please feel free to have a look at it on IET website, or on some of the libraries. I know that University of York Library have a few of them. Thank you very much, and I am here for your questions if there are any.